Good evening. We are going to discuss application of numerical methods in curve fitting of tabular data. Synopsis. We are going to discuss in introduction, curve fitting, linear curve fitting, polynomial curve fitting, overfit or underfit, conclusion. Introduction. Historians attributes the phrase regression analysis to Sir Francis Galton 1822 to 1911, a British anthropologist and meteorologist who used the term regression in an address that was published in Nature in 1885. Galton used the term while taking off his discovery that offspring of sweets did not tend to resemble their parent seeds in size, but to be always more numerical, that is, more average than they. The experiment showed further that the mean filial recursion towards mediocrity was directly proportional to the parental deviation from it. Curve fitting motivation. For root finding, we used to given function to identify where it crossed 0, where does f of x is crossed 0 or not. Analytical methods of phenomena, for example, equation from physics, create an equation from observed data. Interpolation, connect the data dots. If data is reliable, we can plot it and connect the dots. This is piecewise linear interpolation. This has limited use as a general function f of x, since it's really a group of small f of x connecting one point to another. Next, it doesn't work very well for data that has built-in random error scatter. That also is shown in the figure. Linear curve fitting. General form of straight line f of x equal to ax plus b. Why does the blue line appear to use fit to trend better? Consider the distance between the data and points on the line. Add up the length of all the red and blue vertical lines. This is an expression of the error between data and the fitted line. Polynomial curve fitting. Consider the general form of a polynomial of order f of x equal to a0 plus a1x plus a2x square plus a3x cube plus etc plus ax equal to a0 plus a equal to 1 a power x k power k x power k. Just as a for the case for linear regression, we ask overfit or underfit. Overfit. Over during the requirement for the fit to match the data trend order too high. Polynomials becomes more squiggly as their order increases. A sequely appearances comes from inflection functions. Consideration 1. Third order. First inflection. Point fourth order. Second. Inflection points nth order. N minus 2 inflection points that are shown in figure. Consideration aspect 2. Two data points linear touches each other. Three data points second order touches each point. N data points n minus 1 order polynomials will touch each other. So picking an order too high will overfit data. General rule, pick a polynomial form at least several orders lower than the number of data points. Start with linear and add order until trends are matched. Underfit. If the order is too low to capture obvious trend in the data, profit or paste. Straight line will not predict diminishing returns that data source. General use. We view data first, then select an order that reflects inflections, etc. For example, above, obviously non-polar, so order greater than 1. No inflection points observed as obvious, so order less than 3 is recommended. ID uses second order for this data. Conclusion. We see the application of numerical method in the curve fitting of tabular data. Thank you.